Imagine standing on a world with no clouds, no water, no sound. A dead planet, yet beneath its silent dust lie secrets that could shape humanity's future. For years, we thought we knew the moon, but in truth, most of what we've explored came from one side, the side facing Earth. The other half, darker, deeper, and now astonishingly different. Today, one nation isn't just returning to the moon, it's quietly decoding it, layer by layer, rock by rock. Not the United States, not the former Soviet Union, but China. From regions untouched by humanity, the frigid South Pole and the perpetually hidden far side, China has achieved unprecedented landings. They've uncovered rocks never seen before, samples from the moon's mantle, traces of water and helium-3, an element that could revolutionize how we generate energy. This isn't just a story about the moon, it's the start of a global shift, where space exploration is no longer symbolic, but a long-term strategy. Join Top 10 Discoveries official to explore why China is gaining ground on the moon and how this could reshape global technological and strategic dynamics in the decades ahead. The far side of the moon is often called the dark side, but that's a major misconception. In reality, this surface receives sunlight just as regularly as any other part of the moon. What makes it dark is that it never faces Earth, and for most of human history, it remained beyond our sight, reach, and understanding. Then in 2019, a historic turning point occurred. China became the first nation in human history to successfully land on the moon's far side. The Chang'e 4 mission didn't just carry a lander. It deployed the Yutu-2 rover to a region no astronaut had ever set foot on. This wasn't just a technical milestone. It was a quiet but powerful statement that this once overlooked space is now being systematically explored. To make this seemingly impossible feat a reality, China launched a relay satellite named Qiqiao, positioned at the Lagrange L2 point, a gravitational balance point between Earth and the moon. This enabled continuous communication from the other side to Earth. No longer the moon's dark side, the far side has become a symbol of a new approach, cautious, thorough, and ambitious in space exploration. And in this forgotten place, a series of unimaginable discoveries began to emerge. Throughout the 20th century, the US Apollo missions brought back hundreds of kilograms of lunar rocks. But due to technical and safety constraints, astronauts could only land on wide, relatively flat plains near the equator, areas ideal for landing, but less valuable for deep geological insights. They only scratched the surface. In 2019, China's Yutu-2 rover went further. At the von Karman crater, part of the South Pole Aitken Basin, one of the moon's oldest and largest impact scars, Yutu-2 discovered rocks humanity had never seen. Beneath the silver-gray dust, mineral samples emerge. Analysis revealed olivine and pyroxene, minerals typical of the mantle, the layer between the moon's outer crust and inner core. These weren't weathered surface rocks. They were remnants from the moon's very guts. This was a historic moment. For the first time, humanity didn't just see the moon, it touched its deep geological layers. Why does this matter? Because the mantle holds the most pristine records of a celestial body's formation. It's the geological notebook documenting events, impacts, and thermal and physical processes from the dawn of time. To understand how a planet formed, evolved, and might endure, we must grasp its inner structure. With the moon, that had never happened until Yutu-2 opened the first door. 4 years after Yutu-2's feat, China pushed exploration boundaries further. In 2024, Chang'e 6, the first mission in history, returned samples from the moon's far side. What they contained left scientists in awe. One analyzed rock was a 4.2 billion-year-old basalt, the oldest lunar sample ever directly collected by humans. But that wasn't the most shocking part. Among the samples, researchers found younger volcanic rocks, just 2.8 billion years old. Why does this matter? According to the widely accepted Big Splash theory, the moon formed after a massive collision between early Earth and a Mars-sized planet. In that model, the moon, smaller, with no atmosphere or significant internal heat, should have cooled quickly and ceased geological activity early. But Chang'e 6's rocks tell a different story. They show volcanic activity persisted on the moon billions of years after its supposed geological death. This doesn't just challenge the Big Splash model, it forces scientists to rethink how we understand the thermal evolution and internal structure of airless celestial bodies. The moon, long seen as a dead and cold satellite, may have lived longer than we thought. And if so, we might be underestimating the dynamism of other worlds in our solar system. Connecting these discoveries, the far side isn't dark, the mantle was accessed for the first time, and volcanic rocks are younger than expected, we no longer see a static moon. Instead, it's a complex world, gradually revealing ancient mysteries and possibly holding clues to Earth's own formation history. This isn't just a scientific journey, it's a redefinition of a celestial body we thought we knew. In a lunar dust grain so tiny it's nearly invisible to the naked eye, Chinese scientists found something no nation, not even the US during Apollo, had ever detected: Changesite, Y, an entirely new mineral, officially named and confirmed by the International Mineralogical Association in September 2022. This crystal isn't just unique in form, a transparent, columnar phosphate structure, but more critically, it was found in young volcanic basalt samples collected by the Chang'e 5 mission in 2020 at Oceanus Procellarum, a region bypassed by Apollo missions due to terrain and tech limitations. What's most astonishing isn't its shape, but its composition. Changesite, Y, appears to contain helium-3, a rare isotope nearly absent on Earth, but considered the top candidate for clean fusion energy in the future. In a world grappling with energy crises and the fallout of fossil fuels, a discovery like Changesite-Y isn't just a mineralogical milestone. It could be the first piece of a space-based energy economy. Why is helium-3 so significant? Unlike uranium or plutonium, helium-3 fusion produces no free neutrons, resulting in minimal ionizing radiation and no long-lived radioactive waste. If successful, helium-3 could yield energy dozens of times greater than oil or coal, yet entirely clean and safe. On Earth, the planet's magnetic field blocks most solar wind, the primary source of helium-3, from reaching the surface, making it virtually non-existent. The moon, with no atmosphere or magnetic field, has accumulated helium-3 in its regolith soil for billions of years. In that tiny lunar dust grain, containing Changesite-Y, scientists found helium-3 traces for the first time in a stable mineral form. Geopolitically, this is a quiet but profound turning point. Discovering Changesite-Y makes China the third nation, after the US and USSR, to identify a new mineral on another celestial body. More than that, it signals the global interest in lunar resources is accelerating, with the moon transforming from a scientific symbol into a future energy frontier. Technologically, detecting a micrometer-sized crystal in hundreds of grams of lunar soil, then analyzing its composition, structure, and link to helium-3 showcases extraterrestrial material analysis capabilities few nations possess. In short, Changesite-Y isn't just a geological find. It symbolizes three things. Space technology is entering a resource extraction phase. Clean energy from space is no longer an impossible dream. The moon, long seen as static, is offering insights that may redefine how we approach future energy innovation. For nearly a century, humanity has dreamed of a near-perfect energy source. High efficiency, zero carbon emissions, no radioactive waste lasting millennia, and completely safe operation. Helium-3, a rare helium isotope, is currently the leading candidate to make that dream real. Unlike uranium or plutonium, helium-3 fusion produces no free neutrons, avoiding ionizing radiation and the hazardous waste of traditional nuclear reactors. Why does Earth lack helium-3, but the moon has plenty? Earth's magnetic field, a natural shield protecting life from solar wind and high-energy particles, also blocks helium-3 from reaching the surface. Solar wind, a constant stream of particles from the sun, is the main source of helium-3, but Earth retains almost none. The Moon, with no magnetic field, has slowly accumulated helium-3 in its regolith, the fine gray dust covering its surface, for billions of years. Based on data from China's Chang'e 1 satellite, combined with international research models, scientists estimate the Moon holds approximately 660,000 tons of helium-3. This isn't just a massive geological figure. It could transform humanity's energy future. Specifically, approximately 370,000 tons lie on the near side, more accessible to current missions. Approximately 290,000 tons are on the far side, harder to reach but less disturbed, preserving this rare resource intact. Remarkably, just 200 tons of helium-3 could power the entire US for a year, an energy equivalent to hundreds of millions of oil barrels, but cleaner, safer, and free of greenhouse gases or radioactive waste. Beyond energy potential, helium-3's distribution has deep strategic implications. Most large helium-3 deposits are in areas untouched or undisturbed by humans, meaning the first nation to access them gains a massive advantage in the space race, scientifically, economically, and technologically. With each ton of helium-3 worth billions in clean energy potential, the Moon is no longer just a place to explore. It holds untapped scientific and energy potential. Helium-3 is the ideal fuel for the space age, clean, high-yield, and free of radioactive waste. But a stark reality remains. We don't yet have commercial fusion reactors capable of using helium-3. Major projects like ITER, led by Europe, and Spark, developed in the US, are pouring resources into fusion tech, but they're still in prototype stages. The hoped-for timeline for commercial power production, if not delayed, is post-2045. Moreover, helium-3 fusion requires even harsher conditions than the more studied deuterium-tritium (DT) reactions. Helium-3 avoids neutrons, making it safer, but demands higher temperatures, more sophisticated plasma control, and stronger magnetic fields. These make the engineering far more complex and costly. In the 20th century, oil shaped global dynamics, from trade to policy to geopolitics. If helium-3 becomes the energy source of the future, that role could repeat on a new stage, the Moon. Whoever develops helium-3 technology will shape the future energy landscape, hold a long-term strategic edge in global energy, have the power to set new clean energy standards, not just follow them. The Moon could become the next global energy frontier, not for oil, but for the most valuable clean energy source in human history. The road is long, but if the 21st century is the era of green energy and space conquest, helium-3 will be a key chapter, and the nation acting first will write its opening pages. Over 50 years ago, humanity set foot on the Moon. But the truth is, we explored only a tiny fraction. The entire Apollo astronaut missions covered approximately 25 square kilometers, about 1/5 the size of Disney World. Why so little? Technology and safe access limited them. Astronauts could only land on flat equatorial regions, easy to reach and communicate with Earth. As a result, our foundational knowledge of the Moon for half a century was based on samples from a very small area. China's Chang'e missions, especially Chang'e 4, 5, and 6, have brought a flood of new data from previously unexplored regions, like the far side and isolated volcanic domes. Notably, this data is raising big questions about once foundational geological theories. For example, Chang'e 6's rocks suggest the Moon had volcanic activity far longer than the Big Splash model predicted. Chang'e 4's mantle minerals show the Moon's deep structure isn't as uniform as assumed. Even the idea of Earth and the Moon forming as twins after a giant collision is being reconsidered, as the far and near sides show greater chemical and age differences than imagined. Science isn't a collection of absolute truths. It's a system of values constantly updated. What's happening with the Moon proves it. New data shifts perspectives, and the world shifts with it. What we once believed true may be just incomplete pieces of a much larger puzzle. If Apollo opened the first door, Chang'e's data is expanding the scientific map, pushing beyond limits once thought unbreakable. This isn't just space exploration, it's a reminder of knowledge's humility. and the power of asking the right questions at the right time. If the 20th century space race was defined by speed, who reached the moon first, the 21st century is shaped by a new metric. Who has the longer vision, greater persistence, and stronger foundation? In that game, one nation is quietly building an edge, step by step. Instead of chasing flashy moments, China is pursuing a resilient, systematic strategy. Each mission isn't just a discovery, it's a brick in a long-term lunar future. The ILRS, International Lunar Research Station, embodies this. Not just a science outpost, but a collaborative vision where data, tech, and resources integrate into an open platform. Continuous robotic missions, far-side sample returns, water and rare mineral discoveries all show China isn't just probing, but laying the groundwork for a future space economy. In contrast with Apollo's brilliant legacy and iconic tech breakthroughs, the US remains a central player in space. The Artemis program is a vital Xiaoyibu, aiming to return humans to the moon and establish a presence at the South Pole. Yet this path isn't smooth. Schedule adjustments, budget constraints, and technical hurdles have delayed progress. Meanwhile, no new lunar samples have been returned since the early 1970s. Still, America's scientific and technological prowess remains a force no competition can overlook. What's striking is, the moon is no longer just an exploration symbol. It's becoming a strategic platform for the future, where data, resources, and infrastructure will determine lasting advantages. China seems to be capitalizing on this transitional period. With steady pace, integrated research, industry application capabilities, and clear policy commitment, it's steadily claiming unexplored regions, gathering exclusive data, and testing foundational tech for a self-reliant space future. If the future of energy, data, and resources lies 384,000 kilometers above, those whose early presence could define future norms in space exploration, however quietly, will have a lasting voice in the new order. Once again, the game isn't speed, it's depth. The farthest traveler may not win, but the one who endures will rewrite the rules. While the world debates returning to the moon, China has quietly gone further. They haven't just landed, they've dug into the core. Not just collected rocks, they've found new minerals. Not just observed, they're redrawing the map of planetary origins. Now, as the world begins to grasp the boundless potential of helium-3, water-locked-in minerals, and untold stories from the moon's far side, China already holds samples, data, and a long-term plan. No need for proclamations, no need to lead. The reality shows those shaping the future define the present. The biggest question isn't who will reach the moon, but when the future arrives, who's ready? Do you think China could become the first to extract lunar resources and turn that into a global advantage? Or is a larger, quieter competition unfolding? If you believe humanity's next era will be decided not in boardrooms, but on the moon's surface, you're in the right place. Join Top 10 Discoveries Official to keep tracking the journey reshaping the global balance. Don't forget to like, subscribe, and share if this video reveals a glimpse of the future.